All right, so ladies and gentlemen, we're going to get started with chapter 12.3. You guys can see this good, right? 12.3. We're going to go through goal number 1, determine if a sequence is geometric. And that's basically this first box here. It says a geometric sequence of numbers is which consecutive numbers all have a common ratio. That common ratio is just referring to that you keep multiplying every time to get the next number in the sequence. So again, common ratio, we're just multiplying to get the next number. So we're not adding or subtracting, now we're multiplying or dividing. When you're dividing, think of a fraction. What are you multiplying that by? Okay, so if I have 1/2, 1/4, 1/8, ... we keep multiplying by what? What do you guys got? Shout it out. What are we multiplying the top by? What are we multiplying the bottom by? 1/2, 1/4, 1/8. What do we keep doing here? 2. Yeah, so on the bottom, we're multiplying by 2. So that means we're multiplying by 1 on top and 2 on the bottom. That's multiplying by 1/2. Very good. Okay, so the idea is we're dividing by 2, and when you divide by 2, that's multiplication of a fraction of 1/2. Okay? Now, if it's not very easy to see what's going on with the R value, we can take this idea where we can take one of the terms, a sub n, and then divide it by the term in front of it, which is a sub n minus 1. So if you wanted to, on this example, you could have taken, like, say, the second term, 1/4, and divide it by the first term, 1/2. Okay, and in that case, we could do a little flippy, multiply by the reciprocal, right? So multiply by 2 over 1. This guy reduces, and turns into 1/2 that way. Okay, so we can always take one of the terms, the third term divided by the second term, or the second term and divided by the first term. And that should help us find out those R values for you pirates out there. So when I look at the next one, I've got 2, or 2 over 1, 4/3, 8/9, 16 over 27, and so on and so forth. What do we keep on multiplying by here? What do you guys see? What's your R value? When it's fractions, I think of what are you multiplying to the tops, and then what are you multiplying on the bottoms? 2, 4, 8. Rach, what do you got?
2 over 3.
Yeah, so we're multiplying to 2 on the top. 2 times 2 is 4, times 2 is 8. And on the bottom, think of this as 1, 3, 9, 27, and so on and so forth. So this is 2/3. We could also take that 4/3 and divide by 2 and reduce, and then eventually get 2/3 that way. Okay. All right. Do we have any questions with what the recursive formula is for this guy? Have we seen recursive formula? We're okay with common ratio. Okay, recursive formula, again, just a reminder. Recursive formula is just stating that, hey, that you know a sub 1, that subscript, a little 1, is the same as a. So a and a sub 1 are interchangeable. So again, big idea. If you don't see subscript there, it's assume you know that's a 1. Okay? And then this just states that, hey, a sub n plus 1 is equal to r times the term in front of that. Okay, so if I want the second term, I'm going to take the first term and multiply it by r. Okay, that's essentially what that says. Okay, so that's the recursive formula. I don't think you need to worry about that so much. We're not going to find, like, solve for the r given like the 10th term and the 100th term or something like that. We're not going to do that with this. Okay, all right. This is the big one. You should know how to find the common ratio. All right, next. It says a geometric sequence with the first term a and common ratio r follows this pattern. If I take a look, my first term is, again, a, right? That's just a sub 1 or a. Well, to get the next term in the sequence, the second term, we multiply it by r. So now we have a times r. Now to get the next term in the sequence, we take a times r and multiply it by r. Well, r times r is r squared, so that's your third term, a times r cubed. or r squared, excuse me. To get the fourth term, we take a times r squared and multiply by r. Now we have a times r to the third. So that's our fourth term, dot, dot, dot. So what you notice is for every term, the exponent of r is always one less than what term you're at. So again, the fourth term, the exponent is 3. For the third, it's a 2. For the second, it's a 1. For the first term, there's none. Well, that's our formula that we can use for a geometric sequence. Okay, so if I want one of the terms, I'm going to take a times r to the n minus 1 power. That's a pretty important formula. I have it boxed up. I just highlighted. I'm putting stars next to it. Okay, that's the big one, guys. That's the one we're going to use a ton. Okay, you might hear me say this is your nth term formula. So if they're talking about finding a term, or the nth term, or the fifth term, or the 100th term, that's the formula I'm going to use. Okay, so far so good. All right. All right. So let's go ahead and get started. When you guys are doing questions 9 through 18 on homework, it's going to ask you to find the common ratio of this geometric sequence and then write out the first 4 terms. Okay, well, we've been doing this since the first section, 12.1. The sequence that I have is 2 to the n, right? So if I want to find the first term, a sub 1, what do? How do you guys find that first term?
Plug 1 in for n.
Yeah, plug 1 in. And now I'm showing a lot of work. Most of you guys can just do that in your head. 2 to the first is just 2. I'm showing notes. Plug in 2. 2 squared is 4. Plug in 3. 2 cubed is 8. And then plug in 4, and we get 2 to the fourth, we know is 16. Okay, so these are the 4 numbers I would plug in. Once you got 2 or 3 of them, it should be very clear on what r is. So we need our common ratio. What do we keep multiplying by to get the next number in the sequence? Yeah, Adam says 2. And there we go. So we have our common ratio. Okay, so let's find the common ratio. Did it, write out the first 4 terms, done it. Easy peasy, lemon squeezy. Now it could get tougher. If you want to see example 2, I can walk you through that. Do you guys want to see that, or are you able to find that one out? We're okay? Give me a thumb. Thumb up means move on. Thumbs up, thumbs up. Nobody needs to see that one? Okay. Then I am moving on. So skipping number 2. I don't want to bore you to death. All right, now, guys, these are the first 3 questions I put on the test usually. Okay? So when you're doing your homework tonight or tomorrow during your Wednesday time, 69 through 82, they ask you to determine whether the given sequence is arithmetic, geometric, or neither. If the sequence is arithmetic, come up with D, your common difference. And if it's geometric, come up with R, your common ratio. And then if it's neither, you just say neither and you move on. Okay? So they give you our sequences there. I got 3 quick examples. Well, how do I tell if this thing is arithmetic, geometric, or neither? What do you guys got to do? Any ideas, suggestions?
Plug in 1.
Yeah, plug in 1, plug in 2, plug in 3. Well, let's look at what this thing's got, right? So plug in 1, I'll show a little bit of work for the first one. So a sub 1, 1 plus 2 is 3. Plug in 2, 2 plus 2 is 4. Again, I'm showing work just for the first one, just so you can see. Plug in 3, 3 plus 2 is 5. I usually plug in 4 numbers, just so I have a pretty good idea what this thing looks like. So here's my sequence, 3, 4, 5, 6. Okay? Again, you don't have to show work. I probably wouldn't. You can do that stuff in your head. But from here, I can definitely tell what sequence we got. Is this arithmetic, geometric, or neither? What do you guys say online? Josh, Lorelai, Zach, Lisa, Leo, Dylan, Jess, Raman. What do you guys see? Arithmetic, geometric, or neither? Shout it out. 3, 4, 5, 6. Are we adding? Are we multiplying? Or neither? Yeah, arithmetic. And D value is what we keep going up by. It's very clear we're going up by 1. We just keep adding 1 every time. Okay? So that's my answer. So I look at the next one. I plug in 1, I get 4. I plug in 2, 4 squared is 16. I plug in 3, 4 to the third is 64. And I plug in 4. What's 4 to the fourth? 4 to the fourth, 256. So I plug that in. And now I have an idea what the sequence is, right? So I take a look. I kind of just rule out arithmetic. If I go from 4 to 16, that's adding 12, right? But 16 plus 12 is not 64, so I can cross off arithmetic. Then I look at geometric. From 4 to 16, I would have to multiply by what? 4? Is 16 times 4 64? Take a look. Is 16 times 4 in your calculator 64? Yes. Is 64 times 4 256? Yes. So I know I keep multiplying by 4 to get the next number. I know this is geometric. And then that R value is 4. If you need to, take the second term, 16, and divide it by the first term. Take the third and divide by the second. Take the fourth, divided by the third, and you will see you are dividing and getting 4 every time. So my answer there is definitely geometric. Okay. Last but not least, when you're simplifying number 5, make sure you, please excuse my dear Aunt Sally, make sure you square it first and then multiply by 3. So when I plug in 1, 1 squared is 1, and then multiply by 3, I get 3. Plug in 2, 2 squared is 4. 4 times 3 is 12. Plug in 3, 3 squared is 9. 9 times 3 is 27. And then plug in 4, 4 squared is 16, and 16 times 3 is that 48? Okay. So I go through the process. Is it arithmetic? Well, from 3 to 12 is 9, right? So 3 plus 9 is 12, but 12 plus 9 is not 27. So I know I can cross off arithmetic. Then I do geometric. Well, 3 to 12 would be 4, right? Multiplying by 4, but 12 times 4 is not 27. So I know it's not arithmetic. I know it's not geometric. It's neither or neither. And if it's neither or neither, you just write neither or neither. And you don't have to do anything else. You don't need R or D because there is no R or D. It's neither. Okay, so usually this is the first question I ask on your test, the first 3 questions. You should be able to look at a sequence in terms of n and identify if it's arithmetic, geometric, or neither. Okay? Oh my gosh, it's freezing. All right, ladies and gentlemen, let's move on. Does anybody have questions? It's easy, right? Easy peasy. All right, here's that formula again. Oh my gosh. I got A sub n equals A. A, like you're from Minnesota. Yay. A times R, like you're a pirate, and then n to the minus 1 power. Okay. So anytime they're asking me for the nth term or the 5th term or the 11th term, we're using that guy right there. Okay. So when you're doing your homework tonight, when you're doing problems 19 through 26, 33 through 40, okay, so you pick on question number 5 and then look in the left corner, it says 12.3, number 17, or excuse me, number 21. Look back at these examples, all right? It says find the nth term of the geometric sequence whose initial term A and R are given. And then what's the 5th term? So there's 2 things that I got to come up with. All right, so I got A and R. So the first thing is I want the nth term. So I'm going to use my nth term formula. I'm going to plug in A is 2. Then I'm going to plug in R is 4. So I usually put parentheses here. So I've got 2 and then times. For times, I usually put parentheses around that. And then n minus 1. What I don't want to see you guys do is then multiply the 2 and the 4 together and give me 8. You can't do that. That breaks the Deer and Sally rules. So do not try to simplify it. There's not a whole lot of simplifying we could do here. One thing I could do is I could change this 4 to a base of 2. I can make that 2 squared and then simplify it this way, but my math lab should accept this answer. Okay, so when in doubt with geometric sequences, do not simplify, just leave it. The bad thing to do is multiply these two and make it a to the n minus 1. You just saw your dear Aunt Sally crying in the corner, right? Because you just ignored her rules. Oh my gosh. Don't make dear Aunt Sally cry. Just leave it. All right. Well, now I want the fifth term when n is 5. So now I go over to a sub 5 and I plug it in. I've got 2 and I got 4 to the 5 minus 1 power. And that's 2, 4 to the 4th. So I go ahead and grab my fancy calculator and plug that in. 4 to the 4th is what? 256 times 2 is 512, but let's just double check, I think. I have 2 times 4 raised to the 4th. Nice thing is your calculator will follow those Dear Aunt Sally rules for you. And we get 512. So we get a to the 5th is 512. So those are my 2 answers I'm looking for. This is a sub n. This is a to the 5th. Okay. Do you guys want to see number 7 where you see an R value as a fraction? Maybe do that one real quick because fractions freak people out. Okay. It is as easy as example 6 though. But fractions freak you out. So we want to freak you guys out. So I got a sub n equals a times r to the n minus 1 power. They gave us a and r, so we just plug that in. So I've got 6 and then times. I usually use parentheses like that. And then n minus 1. Can I take 6 times 1/2 and make that a 3? Please don't. Okay? Please don't. Your dear aunt, if you do that, Aunt Sally is in the corner crying. You don't want to make her cry. You can't do that. Right? That's crazy. You can't go through exponents like that. It's, oh man. Okay? So that's it. That's all you do for that one. Now I want a to the 5th. So now I plug in 5. So I've got 1/2 to the 5 minus 1 power. Okay, then I got 6 times 1/2 to the 4th. Okay, and that's where I would grab a calc, throw that in, and I got 6 times. You can use 0.5 if it's a nice pretty fraction like that, or use parentheses, 1 divided by 2. If you're doing the fraction 1/2, put parentheses around it. All right, just to make sure there's no issues. So I raise that to the 4th power, I press enter. And then you guys are typing, some of you guys typed in the decimal, right? And then you got the problem wrong yesterday because there's blue font on my math lab that you guys, for whatever reason, it's invisible when you take quizzes and tests, where it says write as a simplified fraction. Okay, make sure if you need to math frac that. So my math lab will mark that wrong, those dirty dogs. I would accept it, but they want the fraction, so math frac it if you need to, and you should get 3/8. So now I've got the nth term, and now I got the 5th term. Okay, so looks super scary with a fraction. It's easy, I promise. It's easy. Okay. All right. How are we doing so far? I know this is not the most exciting stuff in the world, but it's not that bad. Oh, man. Don't skip the word problems. There's a good one. I think there's a good one on there about a knight and a king and, oh, man. Or a farmer and a king and a chessboard. Oh, that's a good question. All right, it says find the indicated term of each geometric sequence. So when you're doing problems 27 through 32, this is very similar to the other ones we just did. Okay, so they want us to come up with the 11th term of this sequence. Okay, now I know some of you guys are very smart and you could just keep multiplying by r to get that number. But again, if it's like the 120th term, I'm not going to do that 120 times, right? That'd be silly. So I want to go through this as easy as possible and just use your formula. It makes it very easy to use. Okay. So when we do this, we got to know these three things. We need to know our first term, A. We need to know our common ratio, R. And we got to know N. Well, N is what term we're doing. So N is 11. We're doing the 11th term. What's A and what's R? What's our first term? What's our common ratio? What do you guys got? 4 is our first term, right? This is A. And then what are we doing to get the next number in the sequence? Max says dividing. We're dividing by 2, and which is like multiplying by 1/2. Very good. All right, so we're, if you're not sure, take the second term and divide it by the first. Take 2, divide by 4, and we get 1/2. Okay, so we're dividing by 2, which is multiplying by 1/2. Awesome. Well, now all we do is we plug it in. If I want the 11th term, I got my A value, I've got R, and now I've got 11 minus 1. Again, that's for notes. If this was me, I'll just go right to the 10th power. Okay, and then I plug it in. So I got 4. I would probably do 0.5 here, but I'm going to do a fraction. 1 divided by 2, close it. And now raise it to the 10th. Okay, and now if I type this into my math lab, guess what? It's wrong. Math bracket. Okay, they always want simplified fractions. So final answer, the 11th term is 1 over 256. Okay, so final answer, 1 over 256. So far, so good? All right, example 9. We got to do example 9 because they're decimals, right? You guys freak out with decimals and fractions. Let's not freak you out here. All right, so when we're doing 9, I've got the 8th term of this sequence. I got 0.3, 0.03, 0.003, and so on. Again, we're using our formula. Anytime I need the nth term, or in this case, the 8th term, we use this guy right here. And I need to know these three things. I need to know A, R, and N. Give me something you know. What is one thing you know? A, R, N. What do we know? Jess, Dylan, Ariel, Joe, Janelle, Dylan, Cassidy. What do you guys know? A, R, N. Chris, Connor, Caitlin, Joe. Shout them out. What do you guys know? What's the first term? What term are we doing? Use your microphones.
N is 8.
N is 8. Awesome. Adam, what'd you say? A was what?
3.
Yep.
Oh, 0.3.
0.3. Awesome. Thanks, Joe. Thanks, Adam. And now R, remember, we're just taking the second term and divide it by the first. We can take 0.03 and divide by 0.3. So in my calculator, we don't know what that answer is, we just take 0.03 and divide by 0.3, and I get 0.1. Okay. If you want to make that math frac, if you want to make that 1/10, you can. I just noticed that these guys are all decimals, so I'm just going to give my answer as a decimal in this case. I'm guessing that's going to be okay for my math lab. If it says that I need a fraction, I'll math frac it. So I want to find the 8th term. A is 0.3. R is 0.1. So any questions on this, let me know how I got that. I can show you. Just took the 2nd term and divided the 1st. And now I'm doing 8 minus 1. So now in my calc, I'm going to do 0.3 times 0.1 to the 7th power. All right, so I got 0.3 times 0.1 raised to the 7th. And I got 3e negative 8. And we know what that is, right? That's 3 times 10 to the negative 8th. So that means move that decimal place over 8 spots to the left. That would be 0.000000003 or something like that. Okay. All right, all right. Any questions? You guys okay with that? All right, so even if they're decimals, not so scary, not too bad. Okay. So guys, this is the meat of what you're gonna see tonight. All right, just coming up with the nth term and the 11th term or the 20th term or the 100th term or what have you. Okay. Well, now we're gonna switch gears on you. And I want to go over the next 2 examples. And what we have now is sum. Okay. So we have sum. Sum means we are adding these all up. Okay. So if I take a look at example 10, now I'm taking this sequence and I keep adding over and over and over. Okay. Well, there's a formula for sum. This is your sum formula for geometric. I'm going to take the first term, A, and then multiply it by 1 minus r to the nth, and then divide it by 1 minus r. Okay, that's the sum formula. I don't have time to show you how it was derived, but that's the idea. Okay, over here they're just saying r can't be 0, because if r was 0, then I would have a times 0 times 0. I would have a bunch of zeros then in my sequence. That would be silly. And then r can't be 1 because 1 minus 1 is 0, and I would just have 3 and 3, and I would just have a repetitive sequence here. So r has to be something other than 0 and 1. No big deal. You won't see 1 with 0 and 1. Okay? So they're going to ask you to come up with a sum on problems 41 through 46. And they give us our sequence here. I got 1/2 plus 1/4 plus 1/8 plus ... plus 1/2 to the n power. Well, if you see an n here or on your last term, then your answer is going to have an n in it. Okay? If you see a number, it's all numbers here, then your answer will be a number. So when I take a look, I want to find the sum. I'm going to take a 1 minus r to the nth over 1 minus r. Now we've been dealing with this sequence before. We know a is our first term, that's a. So a is 1/2. And then we keep multiplying by the same thing over and over and over. And that's 1/2. Okay? So I have 1/2, 1/4, 1/8. I keep multiplying by 1/2. You guys okay with that? So a is 1/2. Okay, and now I plug in 1 minus 1/2 to the n power. Again, if that is an n, then this is going to be an n in our problem. And then I have 1 minus r, which again is 1/2. Okay. Now, usually when you simplify these, it's always going to simplify the exact same way. You look at your bottom here, and you simplify it. Okay, so I'm going to rewrite it right here. So I've got that 1/2 in front. And now that's times this fraction, 1 minus 1/2 to the n. And now 1 minus a half, we know is 1/2. Okay, so far so good. Well, now when I look at this, this freaks me out because I have this fraction and this little red fraction in there. So what I can do is I can multiply by the reciprocal to get rid of it. Okay, so basically what I do is I'll multiply the bottom over here by the reciprocal, which is in this case 2/1, and then I do it to the front as well, 2/1. So whatever this fraction is here, multiply the reciprocal to the front, and that way these guys cancel. And it just so happens these guys cancel. And what it does is leaves you with your numerator, which is 1 minus 1/2 to the n power. And that's it. Everything else has been canceled out, and that's my sum of this sequence. Okay, now what this formula allows me to do is find the sum of as many terms as I have here. So for example, if I want to find the sum of the first two terms, 1/2 plus 1/4, we know if I have half of a pizza and a fourth of a pizza, now we have 3/4 of a pizza, right? Well, I could plug that into this calculator here, this little formula. If I do 1 minus 1/2 or 0.5 raised to the second term, that gives me 0.75. If I want to find the sum of the first three terms, 1/2 plus 1/4 plus 1/8, I can plug it in here. So 1 minus 0.5 raised to the third power. And we got 0.875. Well, that is 1/2 plus 1/4 plus 1/8. Okay, does that make sense? So that's what that formula allows us to do, is find the sum of that sequence. Okay. All right, so the next question we have is 47 through 52. As we take a look, it says use your graphing calculator to find the sum, S of n. All right, so we got 47 to 52. We got 1/2 plus 1/4 plus 1/8 plus ... plus 1/2 to the 15th power. When I see a number here, then I know my final answer is going to have a number in it. And it does ask me to use my calculator, so I am going to use that summation that we've talked about in the past. Okay, and we're going to start when n equals 1. Now the problem is I don't know the sequence. I don't know this guy. I don't know a sub n, my sequence in terms of n, and I've got to figure that out. The other thing I don't know is where do I finish? What term is 1/2 to the 15th? I think it's 15, but I'm not sure. I'm going to show you how to confirm that in a sec. Okay, so I don't know these two things, a sub n and n. So off to the side, I'm going to use that a sub n formula that we got. A times r to the n minus 1 power. We know a is our first term, which is 1/2. And then r, we keep multiplying by the same thing, which is 1/2. And now that's the n minus 1 power. Okay. Now technically, because these guys have the same base of 1/2, I can simplify this a little bit. Just like back in the day when we had x squared times x cubed, we can add those exponents and get x to the 5th. Well, same thing. This is a base of 1/2 and 1/2. I can add these together. 1, I'll write that over here, plus n minus 1. Well, that's equal to n. So if I simplify this, we get 1/2 to the n power. Okay, and that is my a sub n. This is 1/2 to the n. Well, now I want to know what term this is, and now it makes it very clear. Well, if 1/2 to the 15th power is equal to 1/2 to the n, if this is 15, the bases are the same, my exponents must be equal. So I know this guy's 15. And now what I can do is I can find the sum of this sequence from 1 to 15 using my calc. So I'll go ahead and throw it in my calculator. Take this thing out, turn it on. I go to math menu. I go all the way down to the summation, which is 0. And instead of n, I'm going to use x's, so I'm going to use x and 1. I'm going to the 15th term. And then the sequence I'm using is 1/2, so parentheses inside of that parentheses, so parentheses 1 divided by 2, close it, and then raise it to the x power. And then I press enter, and there we go. We get 0.999694824. Now, again, you can try math fracking that one, but I think it's not going to work out for you. All right, so that's what I would plug into my math lab. My final answer I get is 0.999969. Okay, pretty darn close to 1. All right. All right, so that's, again, what we call a finite sum, where I'm adding from one term to a certain term. Okay. If we take a look, the next thing we're going to be doing is an infinite sum. Okay, infinite means it just keeps going and going and going. So if you see plus dot dot dot, that means this sum goes forever and ever and ever and follows that pattern. Okay, well, I want you to think about this sequence. If I take a look at this sequence, I have half of a pizza plus a fourth of a pizza plus 1/8 of a pizza. If I think of this sequence, the numbers are getting smaller and smaller and smaller. This pizza is getting smaller and smaller and smaller. Okay, well, eventually, if I keep adding something that gets smaller and smaller and smaller, then I'm eventually adding a half of a speck of pizza, and then a fourth of a speck of pizza, and then a 1/8 of a speck of pizza. It's going to be so small, you're going to be like adding nothing eventually. Okay, if you keep going an infinite amount of sum here. And the reason that works is because that R value is a fraction that's less than 1. If R is less than 1, then it's going to start what we call converging on a certain value, because eventually you're going to be adding nothing. Okay, so if the R value is ever greater than 1, then that thing is going to diverge, which means get bigger and bigger and bigger, where if it converges means it gets, this sum is getting smaller and smaller and smaller, and eventually is going to converge on a certain value, and it's never going to go past that. And that's where infinite sum comes in. Okay, so if you guys ever see this, where it's plus dot dot dot, or if you see a summation and it has the infinity sign, there is no infinity sign in the calculator. All we're going to do is use this formula, A divided by 1 minus R. Okay, so when I take a look at our last two examples, find the sum of the infinite geometric series. I see 2 plus 4/3 plus 8/9 plus dot dot dot. That is, again, referring to the infinity sign, going infinite. Then I know that the formula for infinity is just A over 1 minus R. Okay? I take a look at my A value, that's my first term, that's 2. And then R, I notice that it keeps going and being multiplied by 2/3. So my R value, A is 2 and R is 2/3. If you need to take 4/3 and divide by 2, you're going to get 2/3. Okay, so we do a little simplifying. I have 2, and then 1 minus 2/3 is 1/3 left. And then from there, I multiply by the reciprocal, which is 3, or 3 over 1. That guy cancels. And 3 times 2, we get 6. Okay, so the sum of this sequence, the infinite sum, eventually converges on 6. Again, the reason why it converges, it stops at a certain value, is because this R value is less than 1. Okay, it's a fraction, which means the sum, these individual terms are getting smaller and smaller and smaller and smaller, and they're going to get so small that you're going to be adding nothing. So that's the idea. Okay. All right, last but not least, I have example 13. In this case, I know I have my infinite. Okay, I see the infinity sign. This is nothing I can plug in my calculator. This is just using my formula up there. So if I want the infinite sum here, I'm just going to take the A value and divide by 1 minus R. If you're not sure what the A value is, you can plug in a few numbers and see what the sequence gives you. Okay, in this case, I can tell the A value is right in front, just like what I have here. The A value is 5. And then the R value, it's R to the K minus 1. I have 1/4 to the K minus 1. I know my K value, which means my R value is 1/4. So I get 5 equals, or 5 over 1 minus 1/4. So I simplify. 1 minus 1/4 is 3/4. And then I can multiply by the reciprocal here. So 4 over 3, 4 over 3. Those cancel. And then I multiply. 4 times 5 is 20. And then divide by 3. So my sum, the infinite sum, again, converges on a certain number, which is 20/3. 20 over 3. All right? The reason why that works is because this sum, these individual terms, are getting multiplied by 1/4 every time. So every number is getting smaller and smaller and smaller and smaller until, if you think of doing that for thousands of times, millions of times, that is going to be so small that it's going to be like adding nothing. A speck of dust, half of a speck of dust, a fourth of a speck of dust, an eighth of a speck. The thing is getting smaller and smaller. Okay. So, ladies and gentlemen, that is it for chapter 12.3. That gives you everything that you need in terms of a sequence of a geometric sequence, coming up with the nth terms, any term you want to find, and then also what we call a finite and infinite sum. Both of those you should be able to do. Have a great day.